So, good morning, and good morning for me in France. So I will present you this talk about the integration of artificial intelligence into mathematics education, the critical issue of orchestrating learning situations. First of all, I have to thank Professor Nafsha Tiandosh for her invitation and Ganchimeg Baninian for translation. I'm very happy to be with you. I mean, with you, 10,000 kilometers between France and Mongolia for participating to this important event in Mongolia. I have to say that my talk will be quite short because I consider that I have just to introduce things for discussing complex questions, and we will have time for discussing afterwards, after the lecture and after the following days through YouTube or other distance communication means. So my talk will be divided in 9 points: mathematics education as a history of tools, the role of the teacher as orchestrator of learning situations, artificial intelligence, considering both continuity and ruptures, and a new issue that I would like to emphasize, the distribution of agency. And I will introduce the notion of ISO, orchestration as regulation of agency. Then showing some key dimension of ISO and some guidelines, essential guidelines for teachers to design such orchestration. I will provide an example and then evoke some possible implication for the Mongolian context and my talk with 3 propositions. So this presentation addresses a simple but essential question. What does it mean to integrate artificial intelligence in mathematics education? And I think that in the Mongolian context, this question takes on particular significance because in Mongolia, education is organized across a very vast territory with strong contrasts between urban and rural areas. Your capital city is facing congestion while remote regions face issues of access. At the same time, your country, there is an increasing engagement with digital resources, including platforms such as GeoGebra and other open educational resources. So these conditions invite us to think carefully about how learning situations are designed and organized. My central argument is the following. The key issue is not artificial intelligence in itself, but how we could orchestrate learning situations in which AI may take part. As a first example, I asked ChatGPT to provide me a map of Mongolia. And so she gave me a map, but I have no means for deciding if it's correct map or not. And thanks to Ganchimeg, I had another map that I suppose is correct one, but it addressed first an essential question. When we get a question, something, an information from AI, how we could decide if it's real, true, correct answer or not. So my first point is mathematics education has a history of tools. Learning and teaching mathematics has always involved tools. Since the beginning of history in the scribe school, for example, these tools may be physical, such as rulers or compasses or abacus, like this Chinese abacus on the screen, or symbolic, such as algebraic computation. More recently, digital technologies such as calculators and dynamic geometry have expanded the range of possibilities available to teachers and students. But we have to be aware that each new tool brings both opportunities and constraints. It can facilitate certain type of reasoning while obscuring others. It can support exploration, but also encourage superficial use. For this reason, tools do not determine learning outcome by themselves. And this leads to this fundamental point. The effectiveness of tool depends on how it is used within a learning situation. And it leads to my second point, the essential role of teacher for orchestrating learning situation. To conceptualize this role, I have introduced the notion of instrumental orchestration. An instrumental orchestration refers to the work of the teacher in designing learning situation, organizing the use of tools, adapting instruction in response to student activity. You can see on my screen what I call the Sherpa student configuration for using calculators at the beginning. When the first symbolic or graphic calculators appeared, I use such a device that allows the screen of a student to be given on the collective blackboard. So the teacher, as well as the students, could follow what this student was doing on her own computer. So it was a necessity for facing the intimacy of small screens, fighting against the confusion between mathematical objects and their representation on screen, avoiding the development of parallel conceptualization, and trying to manage the growing gaps between students. So for a given tool, calculators, we have to imagine relevant orchestration for taking advantage of these tools. So, and now we have to face artificial intelligence. And we have to consider both continuity and rupture. Continuity because artificial intelligence is part of this long history of technological development. In this sense, it represents a kind of continuity. But in the same time, there is a strong rupture because traditional tools execute commands. You ask and they propose a given answer. They remain passive. Artificial intelligence, by contrast, is capable of generating responses, of course, but also evaluating answers, categorizing student work, and even predicting learning trajectories. So, in this sense, AI appears to act within the learning processes. It does not simply mediate activity, it participates to this activity. This leads to a major conceptual shift. We are no longer dealing only with tools, but with entities that behave as agents. And you can see in my slides the different ways of understanding AI as simple tool, or as hybrid actor, or as partner and agent in the process of teaching. And more we have to consider AI really as partner and not only as tools. So it leads to the new issue, the distribution of agency. In a classroom where AI is present, three types of actors are involved. The teacher, of course, the student, and also the AI system. And each of these actors may produce answers, of course, propose methods, and evaluate results. I asked, for example, ChatGPT for having a drawing of a classroom in Mongolia with AI, and I obtained such setting, and you could have your own opinion on this, where the AI, represented as a robot, is asking a question. No, the teacher, sorry, is asking a question, and the AI is providing the answer. But the central questions concern then what we call the distribution of agency. Who acts? Who has to give the answer? Who decides? And who is responsible of knowledge? So my proposition is to conceive orchestration as the regulation of agency. To address this issue, we propose a concept of AI-supported instrumental orchestration, defined as the intentional and structured regulation of the distribution and degree of agency between teacher, students, and artificial intelligence within a learning situation. And this definition emphasizes that AI does not replace the teacher, but modifies the structure of interaction, requiring new form of orchestration. So the teacher remains central, but not as the sole source of knowledge, but as a regulator of the system. And you can see in the same classroom the teacher asking a question and the students proposing some answer, wrong or correct. And the AI is somewhere in the central of the setting, and the teacher has to decide which role it could have, more or less active, at the beginning or at the middle or at the end of the process. And I think it's quite complex, and so I propose key dimension for defining such an orchestration. And you have 8 dimensions at the right of my screen, but I just would like to emphasize here in my limited time 4 of them that for me are quite essential. The first dimension is delegation. What is the AI allowed to do, supposed to do? Then validation. Who determines whether an answer is correct or not? Then temporality. At which moment does AI intervene? And finally, which is for me very essential, the dimension of sociality. Is interaction individual or collective? I mean, collective, it could be among students, but also collective between students and one AI, or collective between a student and different AI. And it depends, of course, on the context in which taking takes place. It depends on teachers' decision and teachers' learning objective. And I propose also some guidelines, 10 guidelines, but I would like here to emphasize only 5 of them. And for me, they are particularly relevant in the context of AI. First of all, designing meaningful situation. Not only mathematical situation interesting for learning something, but a situation where the contribution of AI could be relevant. Then varying technological environments, sometimes working only with, for example, GeoGebra, or working with GeoGebra and AI, or working without AI. Third, encouraging critical distance. On my screen, we have an example right side. I would like just to say some word, but you could find this example well explained in Facebook or Instagram. I asked ChatGPT this question. You have 4 pictures, but these pictures are from which city? Or the same city, but which city? And ChatGPT answers, okay, I can recognize this. This is the city of Nice, the south of France. But it was not Nice. It was another city, Bastia, the city also in the Mediterranean Sea, that it looks like, but it was not Nice. And I asked ChatGPT, but this was a wrong answer. Could you explain what, for which reason this mistake? And so I have an interaction for trying to understand for the reason of this mistake. And I think that students have to be in this kind of situation. They get a wrong answer from AI, and they have to understand the reason of this wrong behavior of AI. And I have already said that promoting collective work among students and also teachers. I will say something about it later. And the fifth guideline is delaying AI intervention. I mean, it's possible to work without AI. And when the teacher decides to call for AI, it has to be for good reason. And so thinking about the good reason for using AI, I think it's an essential component of this kind of orchestration. And for me, these guidelines aim to ensure that AI supports rather than replaces mathematical thinking. And I have a quite short time, but would I just to say some word about a given situation? This is a problem I worked with my students at the beginning of university, and it's also explained in a post of Facebook. The problem was to determine the number of regions defined in a disk by all the chords whose endpoints are taken from among endpoints located on its circumference. See, on the first circle, you have 2 points and 2 regions. On the second circle, 3 points and 4 regions. And so what could be a result for endpoints? It's a rather complex question. And I managed this with an initial phase of individual exploration without AI. You need just a pen and a sheet of paper for drawing circle, placing points, and counting region. And then a collective discussion about which could be a general result. Then a phase where AI will be introduced to propose alternative methods. And finally, a return to student-led explanation and justification. And I will just say more about it, but in this scenario, AI is not the endpoint of learning. It's not the beginning of learning, but one component within a broader process. So just for going on this problem a bit, if you have 2 points, 2 regions, 3 points, 4 regions, 4 points, 8 regions, 5 points, 16 regions, and then. So everyone could imagine that 2, 4, 8, 16, and then 32. I mean, some power of 2. But unfortunately, if you add another point for n equals 6, you have the number of regions equal 31. So how is it possible to interpret this? We have to understand the reason of being. For which reason? Is there a reason for which, if you add a point, the number of regions will be twice? No. So AI could be useful here for proposing some answers. And AI could provide 2 different answers. The first one is a general answer. The number of regions is 1 plus a number of combination of 2 among n, and plus number of combination of 4 among n, or a recurrence relation. But once the student got this kind of answer, it's just the beginning. The challenge for students is to understand the rationale behind this result, to grasp the computational processes that led to them, and to be able, after working in group, to present them to the entire class. And it's up to the teacher to orchestrate this interaction between students' own computing, discussion within group, and getting some general result from AI. So you understand, imagine the complexity of such orchestration, taking advantage of very powerful means of computing and of proving too. So what are the implications for the Mongolian context? I think that this framework is relevant in Mongolia and in other countries because as I could imagine, your vast territory encourages the development of asynchronous learning formats. Teacher shortages increase the importance of tools that support preparation and feedback. Open educational resources provide opportunities for adaptation and sharing, and collaboration between institutions become essential. And I think also in your context, like in other ones, attention must be paid to issues of digital being. So yeah, read before this lecture some recent studies in Mongolia, which show that teacher-related factors play a major role in students' mathematical experience, particularly in relation to anxiety, and that the impact of ICT depends strongly on teachers' classroom practices. In addition, research on artificial intelligence in education highlights its potential to support teaching and learning processes. Taking together these results reinforce the idea that the key issue is not technology by itself, but the organization of learning situation. As a conclusion, I will propose three perspectives. And I've also asked ChatGPT, could you provide me a drawing making sense or describing what could be the collective work of teachers in a country as Mongolia for designing such orchestration. And I like something in this drawing because AI appears both as a tool for individual teacher with her screen in front of her and for the work of the whole group of teachers. So my three propositions. First, the integration of artificial intelligence is not primarily a technological issue, but an organizational one. Second, about orchestration, AI deeply transform orchestration into a process of regulating the distribution of agency between teacher, students, and AI. Third, and I would like to insist in this transformation requires, and it could work only if you take into account and you develop collective work among teachers in order to design, share, and evolve learning situation. It's not possible for a single teacher isolated to organize such a design and orchestrating process. And finally, artificial intelligence will not transform mathematics education by itself. What will transform it is how teachers collectively organize its role within meaningful learning situation. And it will be the end of my talk. There is some references for understanding or deepening this result, my own references and references by researcher from you or in collaboration with researcher of your country. And I am very happy to be here because it could be like a starting point of an interaction process. And for me, the last a milestone important will be the next International Congress of Mathematics Education, which will take place in 2028 in Europe. And in this, in this Congress, one of the central event will be a plenary panel, and I will participate to this panel on the topic of AI in mathematics education. I am sure that your own experience in Mongolia could also be an element to take into account in such panel. So thank you for your attention, and I will be happy to discuss with you from the questions that we will ask. Thank you very much.